The Library Management System is a database-driven platform designed to manage the operations of a library. It involves and supports operations such as book management, member management, borrowing and returning of books, search and catalog, as well as user access control. Therefore, it allows librarians to track book inventory, manage member information, and facilitate book borrowing and returns. Hence, this system improves the efficiency of library services by automating manual tasks, reducing errors, and providing real-time access to records.
In Phase 1, after drafting the project scope, we then created the ER diagram and the schema design wherein or have identified entities and relationships based on use case, normalize the design to the third normal form, and create a SQL script that defines the schema, which includes tables, keys, and constraints. In this diagram is an entity relationship diagram for our library management system. It includes key entities like books, members, loans, users, and fines with relationships represented by foreign keys. The books table connects the authors, publishers, categories, and loans, reflecting its involvement in loans and classification. Loans track which members borrow which books and by whom the loan was processed through the user table. Fines link to both loans and members, indicating penalties for late returns or other violations.
In Phase 2, we use Python plus Faker in order to generate 100,000 data for each table that we have. As you can see here, we have a total of 9 CSV files, and each table consists of more than 100,000 rows. For authors, we have 110,001 rows. For book authors, 219,986 rows. For book categories, 164,720 rows. For books, 110,001 rows. For categories, 115,512 rows. For loans, 110,001 rows. For members, 110,001 rows. For publishers, 110,001 rows. And for users, 110,001 rows. This SQL script allows to import the CSV files containing the 100,000 plus randomized results from each table, from Visual Studio Code to MySQL Workbench.
In Phase 3, the tasks were to write at least 5 advanced SQL queries with functions like sum or count, filters like where or having, as well as joins, in order to combine tables, and after which transform the database using a star schema after the normalization.
Next, after the advanced SQL queries were written, we then executed each query in order to check whether it displays the expected results. As we can see, after executing the queries, the expected results were displayed in the result grid.
The search and catalog functionalities are central to the library management system, enabling users to efficiently browse and locate books based on various filters. These SQL queries provide the back-end logic for searching books by title, author, category, or availability, ensuring a flexible and user-friendly catalog experience.
The first thing is to go to the path of your MySQL server. And next is use the MySQL dump in order to back up your library MS SQL into your desired folder. Next is, in order to simulate a recovery of the SQL, you need to go and drop the database library MS first. So after dropping the database library MS, so I use the backup.sql in order to recover it. Next is cloud backup. So I use the Railway app. Then I created a new project in the Railway for MySQL. Then in order for me to connect, I copy the raw MySQL command in the Railway app. Then go to the command prompt where MySQL server is, and then paste the raw SQL command in order to import the backup SQL file into the Railway app. So you need to locate that backup file SQL. Next is connecting the Railway to the MySQL workbench, and you have to set up the MySQL connection. The detail is in the raw MySQL command that was used earlier for importing your database to the Railway. Get the host name from there, the port, the username, and the password. Then after that, I tested the connection, and then it is successful. So I ran it, and I can see the schema and the data of my database in the Railway connection.
In Phase 5, which is the query optimization and indexing for scalable databases, several indexes were added, and after the optimization, there have been an improvement in the query execution, wherein the speed and performance became efficient than how it performs previously without the presence of the added indexes.